Hey there everybody, today we are continuing with our inequalities. Today our I can statement is, I can solve multi-step inequalities. And we're going to solve those with things like distribution and with combining like terms. Now I don't have an official notes page for you today, so instead we are going to work the second page of your assignment together, plus a little bonus. We are also going to do number 7 together because that one's a little different. I want to make sure you see that one as well. So you can see I did a little color coding again. I've got some pink circles and I've got some green circles here. The pink ones are all the distribution problems, the ones where we use the distributive property to solve. And the green ones are the ones where we have to combine like terms to solve. Okay, let's go ahead and get started with those pink problems. So if you remember how to distribute, then awesome. If you don't remember how to distribute, I'm going to give you a quick review right now. So when do you need to distribute? When you have these parentheses like this. And so you need to get the m by itself in order to solve this thing, right? But you can't get the m by itself until you get rid of these parentheses. And the distributive property lets us get rid of the parentheses. So what do? We take the 7, whoops, there we go. We take the 7 and we distribute it to both of those terms inside of the parentheses. So we're going to distribute it to the m and to the 6. Now what does it mean to distribute it? It just means that we're going to multiply it. So let's go ahead and work that out. So 7 times m, well, you can't simplify that because we don't know what m is. So we're just going to write 7m, which means 7 times m. Okay, there we go. Now 7 times 6, and it looks like it's a positive 6. So 7 times 6 is 42. Because it's a positive 42, we're going to put plus 42. If it had been a negative 42, we would have put a minus sign there instead. Okay, well we just distributed, yay! Now let's bring down the rest of the problem, which was just like that. And we're going to keep solving. So we need to get rid of the 7 and get rid of the 42 so that we can get that m by itself. We're going to get rid of the number that's not attached to the variable first, and that number is 42. It's sitting over here by itself, so let's let's subtract that from both sides. I'm going to grab my handy calculator, and we'll do 91 minus 42. Looks like that's going to give us 49. So this is going to be 49 is greater than 7m, and nothing to bring down here because 42 minus 42 is 0. Okay, still got to get that m by itself, so let's get rid of the 7. Right now things are multiplying together, so we need to get rid of the 7 by dividing. And I'm going to keep working over here so I don't get into the space of my number line. These are going to go away. They're going to cancel because 7 divided by 7 is 1. Over here, 49 divided by 7 is 7. So you're going to be left with 7 is greater than m. And there was no need to flip our sign anywhere because we didn't ever multiply or divide by a negative number. Okay, so this is how we write the solution to the inequality. Are we done? No, we still got to put it on the graph. Let's do that. Let's draw our 0. Now let's draw our 7. Okay, it's a greater than sign. It does not have that or equal to part, so that means I have to use an open circle. An open dot, right, like that. Okay, now I'm going to read it from the variable. So I'm actually going to read this backwards. So m is less than 7. M is less than 7. So m is all the numbers that are smaller than 7. So it's all the numbers that go this way. If you would rather read it this way, you could say 7 is greater than m. Okay, so 7 is greater than all the answers. So all the answers would be over here where the smaller numbers are, and 7 is over here where the bigger numbers are. Okay, so you've got your solution. You have an open or closed dot, and you have an arrow that points either right or left. At that point, you're done. Okay, let's do another pink problem, and we'll come back to these greens in a second. Okay, let's look at number 13. If you're feeling confident, try pausing the video, see if you can solve this by yourself. If you want to work it with me, that's totally fine too. Okay, so we're going to distribute this negative 2. Don't distribute just the 2. Make sure you distribute the whole negative 2 to everything inside the parentheses. So you're going to distribute it to the 1 and to the 5v. Okay, now let's do our multiplying. So negative 2 times 1 is negative 2. All right, now negative 2 times 5v. Okay, so what you're going to do is you're going to multiply that negative 2 times the 5, and you're going to get negative 10 and then you're going to also put a v on there. So it's going to be negative 10v. And so negative 10v, it's going to look like a minus 10v, but that's perfect. That's the way it should look. Okay, and the rest of it we just bring down, greater than 119. Okay, now we just need to solve for v. Let's do that. Should we get rid of the negative 2 first, or that's minus 10? Get rid of the one that's not stuck to the variable first, right? So that's the negative 2, the minus 2. We're going to do the opposite of it, which is going to be a plus 2 to both sides. And I just wrote that down wrong. Silly me. There we go. Plus 2 to both sides. That's going to cancel out. You're going to be left with negative 10v is greater than 121. Alrighty. Now you got to get rid of that negative 10. So let's just divide by everything we want to get rid of. Right now you have negative 10 times v, so we're going to divide by negative 10 on both sides. And when we divide by a negative, what do we have to remember? We're going to have to remember to flip the sign. I'm going to circle it so that I can't forget. Those are going to cancel out. You're going to be left with v is less than, let's see, 121 divided by 10 is going to be 12.1. But it was actually a negative 10, so I better make that a negative because a positive divided by a negative is a negative number. And so now we have our answer. V is less than 12.1. Let's put it on the graph. V is less than negative 12.1. Yes, yes. Okay, here's our 0. Here is our negative 12. Here's a negative 13. We're going to put our negative 12.1 right here. I'll just kind of squeeze it in there. It's a less than. It does not have the little or equal to bar, so we're going to have to use an open dot, so don't fill it in. Open dot here, and v is less than that, so all the answers are less than negative 12.1, so we're going to draw the arrow to the left again. Okay, and that's how you do that. Let's do another distribution one. Let's look at number 14 this time. Okay, so again, we're going to distribute the number outside the parentheses to everything inside the parentheses. We'll distribute the 5 to the 6, and we'll distribute the 5 to the 3x. So 5 times 6 is 30. And now 5 times 3x is, let's see, 5 times 3 is 15. And then you have to include the x. So 5 times 3x is going to be 15x. Now, was this 15x positive or negative? It was positive because you have a positive number times a positive number. That means the sign that goes here is a plus sign. And then this you're just going to bring down. Okay, we're going to get rid of that 30 first. Let's get rid of it by subtracting it from both sides. Bring down what you can. 15x is greater than negative, let's see, same signs, add and keep, so negative 156 it looks like. And now we're going to have to divide by 15 on both sides. And no need to flip any signs because we didn't divide by a negative. I do need my calculator for this though. Negative 156 divided by 15 is going to be negative 10.4. Okay, let's put that on the number line. So we have 0 here. Let's put our negative 10 here and our negative 11 here. This is feeling a lot like that other problem. Negative 10.4 is going to be between those two numbers. Negative 10.4. You're still going to have an open dot because you still don't have that or equal to part. We'll get to one of those eventually. So let's do an open dot. Now this time it's x is greater than, so you would think that the answers are bigger than or greater than negative 10.4. So where do the bigger numbers live? They live to the right, and we're going to draw our arrow that way. Okay, we have one more distribution problem that I want to show you, and that was number 7 from the first page. So let's take a look at that. Okay, you have 88 is greater than or equal to, finally, negative 8 times a minus 4. So this negative 8 is going to distribute to the a, and it's going to distribute to the minus 4. Okay, so negative 8 times a is negative 8a. That's all you can do there. Now negative 8 times negative 4, because there's this minus sign, I'm thinking of this as a negative 4. So let's see, a negative number times a negative number makes a positive number, right? So I'm going to put a plus sign here, and then I'll think about what 8 times 4 equals, and it was 32. So negative 8 times negative 4 equals positive 32. Okay, the rest of this I'll just bring down. And now let's keep solving. Let's get rid of our 32 first. Let's see, 8 minus 2 is 6, 56 there. Still got this and still got that, but that went away. Now we got to get rid of that negative 8 that's in front of the a. Right now it's multiplying, so we're going to get rid of it by dividing. And, ooh, we just divided by a negative number. So let's circle this as a nice reminder to ourselves to flip it. That negative 8 is going to go away. 56 divided by negative 8 is going to leave negative 7. Let's flip our sign. And then it's just an a on the other side. So it looks like negative 7 is less than or equal to a. This is how we write that solution. And now let's get it on the graph. I'm going to put a 0 here. Here's the negative 7. And we have that less than or equal to. So this time we get to fill in our dot. Okay, let's do it. Closed dot. I'm going to read this backwards to figure out which way my arrow goes. So a, in other words, all the answers are greater than negative 7. So the answers are going to be bigger than negative 7, so the part we want to highlight are all those numbers that are bigger than negative 7. You could also think of it as negative 7 is less than or equal to a, if that makes more sense to you. Okay, we're going back to the other page. Now we're going to do those problems I circled in green, and those are the combine like terms problems. Okay, so we have 6 plus 7f minus 3f is greater than 22. So where are some like terms here? Is there anything like the 6? The 6 is what we call a constant. It's just a number by itself, no variable. That's a constant. Well, there's a constant over here, right? Can we combine those two together? No, let's not do that, because when we're combining like terms, we're only working with one side of the equation. So either that side of the equation or that side of the equation, but we're not combining the sides, okay? So let's see, on that side of the equation, there's nothing to combine. There's only one number. So let's just look at this side of the equation. It looks like 6, and it's not an equation, is it? It's an inequality, but you guys know what I mean. It looks like the 6 is the only constant over here. So we're not going to combine constants. What about variable terms? We have something with an f, and then we have something else with an f. Can we combine those? Absolutely. So we're going to combine it just by thinking about the coefficients in front. So 7f minus 3f, you can almost think of the f like I always use oranges. Think of 7 oranges minus 3 oranges. Okay, you'd get 4 oranges, right? Same thing here. If you have 7 f's and you take away 3 f's, you're left with 4 f's. So that's what we're going to do. I'll bring down my 6, and then I'll say plus 4f. Okay, the rest of this we just bring down. And then from here on out, there's not much new. We're going to get rid of the 6 first. We're going to be left with 4f, because that went away. 4f is greater than, let's see, 16, right? Okay, now we're going to divide through by the 4, and you're going to be left with f is greater than 4. Okay, let's put our 4 on the number line. There's our 0, there's our 4. And now let's graph it. We have a greater than, so we need an open dot. And now let's think carefully about our arrows. F, or in other words, the answers, are greater than 4. The answers are bigger than 4. Okay, we got to go this way. Okie dokie. Just remember, every number line graph needs either an open or closed dot and an arrow that points right or left. If you have those things, you're in pretty good shape there. Okay, let's go to number 11. Again, we're looking at combining like terms. Is there anything on the left to combine? Whoops, there we go. Nope, it's just one number. What about on the right? Anything on the right to combine? Looks like we have one constant, no other constants to combine it with. What about variables? We have something here with an x and something else here with an x. So can we combine those? Yes. Okay, if you have 3 x's and then you take away 8 x's, let's see, what is 3 minus 8? It's going to be negative 5, right? So we're going to have negative 5x here, there. These two became negative 5x. So let's just bring the rest of this down. 24 is less than or equal to negative 6 minus 5x. Okay, from here, all we do is solve. Let's get rid of the 6 by adding it to both sides. You have now 30 is less than or equal to negative 5x. Let's get rid of that negative 5 by dividing it on both sides. And you're going to be left with, let's see, 30 divided by negative 5 is negative 6. Oh, I almost forgot. I'm going to have to flip that sign because we divided by a negative. Okay, so now flip your sign, and then just left with an x over here. Okay, let's put it on the graph. We're going to do 0 here. Let's do -6 there. Are we going to have an open dot or a closed dot? It's going to be a closed dot this time because we have that or equal to component. That or equal to component, it just means that it can include this number also. So like -6 is part of the solution set. You could say -6 is greater than or equal to -6, and that's a true statement, so we're including it. Now I'm going to read from my variables. So the answers, the answers, same thing, are less than -6. The answers are smaller than -6. So the arrow is going to go this way. Okay, we've got one more left to do here. It's -x plus 7 plus 7x is less than 7. Okay, there's nothing to combine over here. It's just one number. So here on the left, what can we combine? So, sorry, just to be clear, there's nothing to combine there, but there is stuff to combine here. So let's start combining. We've got our -x and we've got our 7x to combine. The 7, we can't combine it with anything because there's no other constants. So we'll just do the 7x and the -x. Now -x is the same thing as -1x. So when you're combining, you could think, let's see, if you have 7x's and you take away 1x, you're going to have 6x's left. So we'll say 6x plus 7. Just a quick note here. If you wrote 7 plus 6x, that's totally correct also. And then we're going to bring that down. Okay, now let's solve. You're going to be left with 6x is greater than 0. Okay, divide by 6 on both sides and you're still going to have 0. So this is our solution. Let's put it on the number line. Here's a 0. X is less than 0. So this time we need an open dot. And we need all the answers that are less than 0. So the numbers that are less than 0 are the ones that go out this way. So let's highlight those. And there you go. So I hope that was helpful, and make sure you solve all those problems on the first page. It looks like there's still just 7 left for you to do by yourselves. Thanks for watching. Let me know if you have any questions. Bye.